Tēnā koe. Welcome to the possibly last video in our series of organic chemistry lectures. Oh my gosh, how exciting, last one. Alright, this one I'm going to talk about polymerization. Now, you did some last year. Can you remember what type of polymerization you did cover last year? No? Can you give me an example? Hope you can. Best one you can think of is addition polymers. This is what you did last year. Addition polymers, you need to have multiple bonds, so double bonds, to be able to make them. Easy example would be polyethene, where the monomer is ethene. Other examples would be polyvinyl chloride, or PVC. You know, you have PVC jackets and PVC trousers, okay? Polypropylene, you have a polyprop top you might put on when you're cold. I love my polyprops in winter. I can't live without them. Or polystyrene, you guys know about polystyrene. It's the stuff that, you know, little balls that you can get in your bean bags, and when you buy something electronic and it's all might be nicely packed in the little packaging and all this polystyrene in there. Let's just though have a weird little think about how we did this. Ooh, that's what I wanted. Let's go here. Polymerization. We did that last year. Here we go, and we should go back to here, and then this one. Yay! Okay, so if I had, let's go for ethene because that's nice and easy, and then we'll do another one. So if I have ethene is C double bond C, and this has two hydrogens off each side. Yep. Alright. If I have lots and lots and lots of these, so let's just have two, just so we know what we're doing here. Alright. I have two like this. Okay. If I'm going to add these together, hence it is addition polymers. Okay, under the right conditions, can't remember off the top of my head what they are, but right under the right conditions, I would have C, single bond C, H, 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 H. That's from this one, and then I would have a new bond formed to another carbon, hydrogen, 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 hydrogen. And of course, these two on the ends would also have other bonds to other versions of this. So we draw a little bracket around like this, okay? So what we can say here is we can have this n number of these monomers, and this would make this n, okay? So I make polyethene is, this is the repeating unit, this is the repeating unit, okay, and it keeps on going. Okay, you might have had an example last year where, say, you would have C double bond C, Cl, H, H, H. Oh man, I don't have my favourite one. Oh, it's so good. So this one here, and you might make this, could be a section of your polymer. So have Cl, H, Cl, H, Cl, H, H, H. I need the H stamp again, don't I? Alright, so this here you can see, you can see that this is the repeating unit. Yeah, so that would be your monomer. Okay, I'm hoping you can remember this. Let's finish this off. Here we go. Hoping you can remember this because you need to be able to remember it. That's just all there is to it. I forgot to say, while I was there, one of my favourite examples for teaching year 12 polymerization is actually Teflon. Yep, Teflon is an addition polymer, and you guys know about Teflon because it's the stuff that makes non-stick pans non-stick. Very cool. Go look it up if you're curious. Okay, so polymerization continued on. We have this year we're looking at condensation polymers. So you need to remember all the stuff about addition polymers, but you also need to know about condensation polymers. So condensation of polymers, we can have two types that we're going to look at this year, which are polyesters. So these are nylons, and polyamides, which include proteins. So those of you who are in biology, this is going to be real boring, but from a chemistry point of view. Okay, so polyesters are obviously going to have ester linkages, and polyamides are obviously going to have amide linkages. Okay, so polyesters. Polyesters are formed by the reaction between either a diacid or a diol. So diacid being an acid group that has, carbon chain that has two acid groups. Okay, so I have C double bond O at one end and C double bond O at the other. I'm going to draw these out again so you can have a wee look at them as well. And a diol, so an alcohol, or a carbon chain with two alcohol groups at each end. And then you make the polyester and water. There's an example for you, which I'll draw out in a different way so you can see what it looks like. Or you can use a diacid chloride and a diol, which will again make the polyester and HCl. So again, these things release small molecules, so they are condensation reactions. But of course we're making polymers, so these are condensation polymers. And each unit of the reactions above showing a section of polymer can be referred to as the repeating unit. So you might be asked to draw a repeating unit of something. In fact, it is a very common exam question, and it's really easy to get good marks in if you can just notice it. Noticing it's the hard part. Yeah. Right, so let's see if I can have a go at drawing these a little bit differently for you. Okay, so this first one. So we'd have N being any number, of C double bond O, it's an O, OH, so one acid group. And then I would have 6 more carbons, so let's just kind of pretend I've drawn 6 carbons in the middle of there. And the other end is C double bond O, OH. And again here I have the alcohol, HO, going to a carbon, whole pile of other carbons, another carbon at the other end, OH. Now of course, this being a polymerization and an esterification reaction, this hydrogen, these ones will be eliminated, okay, and this carbon will bond to that O and then onto there. Okay, so you see you have C double bond O, 6 carbons, C double bond O, 6 carbons, single bond O. So this here is the ester linkage. Okay, so here if I was to draw this on, okay, this O would then be combined with another C double bond O, 6 carbon CH2 6 times, C double bond O, single bond O, etc. And this end I could do the same thing. I have O, CH2 6 times. Yep, okay, so you can see it's polyester. Same dealio down here, except you just have, instead of the OH, you have Cl. I hope you can see that. Cool. If you can't, find me, ask me more questions. It's all good. These are again written in page 176 in your book. Polyamides. Reaction between a diacid or a diacid chloride and a diamine will make polyamides and water. Okay, so again, COOH, COOH. Diamine makes this beautiful diamide. Now, this is all well and good. I'll have a little go here while I'm talking of drawing this out again. This is all well and good, but to be honest with you, they don't often ask you a polyamide question like this. They will ask you a polyamide question that is what I'm going to talk about next, which is all about natural polyamides, which is amino acids joining together. Yeah, does that sound vaguely familiar to anyone? Amino acids, lots of amino acids joining together to make shock horror proteins. Maybe? No? Believe it or not, that's just a polyamide. Okay, sweet. Proteins. One example of a biologically important polymer. They are found in all parts of the body as they are the structural components of skin, muscle, hair, while others are enzymes that catalyze reactions in the body. So your proteins are really, really, really important, like amazingly important. If you didn't make proteins, you would be dead. Cool. And I'm sure, I hope most of you, if you're not doing bio, that at least you can remember back to year 11 where you might have done, DNA stuff, right? So DNA codes for proteins, all right? So the DNA codes for all the proteins, and how do you get those proteins to join together? It's the amino acids. The amino acids code for, your DNA codes for amino acids, and the amino acids are joined together to make proteins. All chemistry. Proteins are formed by the condensation of a large number of amino acids. Small molecules called dipeptides and tripeptides are formed by the condensation of 2 and 3 amino acid molecules respectively. Dipeptides 2, tripeptides 3. If 2 amino acids condense to form a dipeptide, there are 2 possible distinct structures. So you can have A and then B joined together by being AB. But of course, because amino acids have an amino group at one end and an acid group at the other, you can also have it round the other way. So you can have B and A joining together. Okay, so here's the example. So you might remember I had glycine and alanine. So this is glycine and alanine. So here, okay, and here, this can join this bit to this bit. So it'll be HHHCH3. So this bit, the acidy bit here will be the CH3E1, which is this one. CH3 with an acidy bit. Okay, so this is B. This is B. This is A. This is A. Yeah, so CHH. Whereas, so that one there, if you think about that, that's this bit. Let me get my pen again. This one here is going to be blue. This one here, this is this bit here joined together. So this bit would be, this bit's left at the end. So that's this one here and this bit here joining together. Yeah. Whereas this one in red, okay, this bit here is the joined together bit, and this is the CH3 one. So this is this bit here and this bit here joining together. Okay? If you don't get it, just sit there and have a look at it for a while. It might kind of click. Alright, so here's a question for you. Draw the 2 possible dipeptides that can be formed when the following 2 amino acids combine. Okay, so have a go at doing that and pause the video and come back and I'll give you the answers. Oh, too fast. Alright, there are the answers. Sorry, it's a bit kind of fuzzy. It's just the way my cutting and pasting from a Word document has unfortunately come in here. Okay. Sweet. Alright, so when many hundreds of amino acids molecules are continually linked by these condensation reactions, proteins are formed. That's how you make proteins. I can pretty much about 95% guarantee that they will put in a question relating to amino acids, dipeptides, tripeptides, stuff like that in the exam, because, believe it or not, my opinion is that when they try to write the chemistry 3.5 exam at the end of the year, they try to be biologically focused because they think that that will be a more of a real thing. Okay, so I reckon 95% sure there will be a question in there relating to amino acids, polymers, condensation stuff. Cool. Or they'll do this one, which is the hydrolysis of proteins and peptides. So how do you break down proteins and make dipeptides or tripeptides? So hydrolysis of the protein or the peptide will produce the constituent amino acids. However, if it's done in an acidic solution, they'll be in the form of the positive ion, same as before we were doing the whole ester stuff. If it's in a basic solution, it'll be in the form of the negative ion. So you think about this in your body, all right? Those of you who are biologists, you'll know that there are specific pHs in your body, especially in very different pHs around the body and depending on what you're doing. So think about it, if you're breaking down proteins and you have a pH that is acidic, it'll be producing the positive ion. Whereas if you have a pH that is more on the basic side, then you'll be making the negative ion in your body. It's quite clever. Okay, so here I want to hear you to have a go at drawing the structure of the amino acids formed by the hydrolysis of the following dipeptide in acidic conditions and basic conditions. Just remembering that this bit here is the bit you're worried about breaking up. This stuff here could be anything. It doesn't matter, alright? Have a go at that, pause the video and come back and have a go at the answers. Alright, there you go. Here's the answers. And my last question for you is experts. Alright, that's us. Good luck.